Hello friends, welcome back. Now let us see some applications of arrays. Arrays can be very well used while storing and accessing the data. When we have one type of data which are in multiple number, then we can store all these data at one place in a successive locations. So it will be easier for storing and accessing the data. It is very convenient when we are searching some element in the set of data. So if the set of data are of same type and if they are fed in any array, then it is quite easy to search the any given element, and we can extend a one-dimensional array into 2D array, which commonly we call matrices, and all associated properties of the matrix can be made use of through 2D arrays. And the same way we can extend our dimensionality to any dimension, maybe 3D, 4D, and so on. So in general, we can talk about any n-dimensional data in the form of an array, and it will be quite easy to store, access, delete, and all that. So to work with data, if it is in the form of an array, it will be quite easy to work on it. And if we have the data structure, that's an array, then this array data structure can further be extended to implement other data structures like queues and stack. So shortly in the coming sessions, we look at what queue is, what stack is, and how they can be implemented using array and any other different methods. And it will be very much helpful in working in dynamic programming for storing the intermediate results. We do require storage place, so the best way to store intermediate results would be storing in an array, and will be very much useful as a data buffers. So when we get a data, we want to keep the data stored there for some time till we read it. So we need some place to store the data, and that's what we call a buffer. So we can make use of the array as a data buffer. Then let's see some advantages of using arrays. Uh, the elements in the array can be very efficiently accessed because it's randomly accessing is possible. Hence, in one time or a constant time, we can access any element, and we do have efficient memory usage. In other types of data structures like linked list or trees or any other thing, we do require additional memories for storing the memory locations and all that. So we look at when we deal with the details like linked list or trees, there we do require additional space for every element to store, and but whereas in arrays we need memory only required for storing the elements, we don't require any additional. Then simplicity is the major advantage of any array. So the arrays implementation, arrays usage, arrays access, deletion, searching, and traversal, whatever activity we take, it's quite simple to implement, and this whole activity can be taken up iteratively, and definitely it is cache friendly. The cache what we have in the processor is type of an array. So it's whatever activities we want for a cache memory, the same activities are possible with an array. Therefore, we do say that it's cache friendly, because in the cache we use a array like structure to save the data, and multiple data items of the same type can be grouped together and placed in one under one umbrella as one name of the array. So usage of the data when they are of large number but of same type, it can be conveniently used if it is shown in the form of an array. And this usage of array can be a foundation for further complex data structures. As we go deep into other data structures, we look in how arrays help in creating such data structures. We just look at that like hash tables and other uh, data structures can be implemented using this technique called arrays. And it's quite easy to organize the data if the data is stored in the form of an array. And we do have a very good language support. That means almost every programming language in some way has provided support to define an array. So this helps us and uh, encourages a programmer to use the arrays, and it can be made sure that through arrays we can reduce the redundancy. Yeah, nothing comes free. So when there are advantages, definitely other side of the coin, there will be disadvantages of using arrays. The first thing is in case of languages like C, C++, this array has to be defined before compiling the code. Therefore, it will have a fixed size. It cannot be changed once compilation is done. Therefore, the problem with arrays is the size of the array will be fixed. So commonly, to make sure that we work without any problem, we try to define the size of the array as the highest possible thing we can think of, how much of the size is required, the worst case, what is the maximum size required, and we define for that. With that, what happens is so much of memory will be reserved for that particular array, and most of the time it is underutilized, and hence the memory, though available unused, but cannot be used for any other purpose because it is reserved for a particular array, and because it is defined during the compilation time only, worst case scenario was thought of, and as per that, as much as possible, highest value of memory is reserved for any given array, and most of the time it is underutilized, and hence inefficient memory usage is other problem with the next problem is about insertions and deletions. So if it is at the end, so it's not a problem. But if it is somewhere in the beginning or in the middle, then the whole thing has to be shifted either to the right or to the left, depending on we are inserting or deleting. So if we are inserting, then wherever we are inserting, first we have to create a void there. So to create the void there, from that point onwards, everything till the end of the array we have with element by element, everything has to be shifted and void has to be created, and then in the void that new data has to be inserted. If we are deleting, then the one value will be deleted. That means a void is created. So to fill that void, all the next data have to be shifted back to fill that void. So just for inserting one or for deleting one element, we need a worst case order of n. So its insertion and deletions are of linear time constant. So it is a little inefficient compared to other things. The other problem with arrays is we need to work with only homogeneous data types when we are working on old languages like C or C++, Java and all that. So when we define an array, then we have to ensure that all the elements of the array should have same data type. So only for homogeneous data types an array can be defined. We cannot have mixed data types under one array, and that's going to be another disadvantage of using arrays. Then, as we discussed, memory allocation is another problem, because when we are defining an array, usually we look for the worst case requirement and accordingly we try to define. And then that is the first issue. Second issue is we want contiguous memory available for this allocation. And even if we have sufficient memory in different location, chunks of memories when added together, even if it is more than what is required, still we cannot allocate this memory, because this whole allocation has to be done contiguous locations. So we need to have at one place memory which is more than what is required. It doesn't make any sense in the whole memory in different parts how much of the memory is available, and summing up totally how much memory available doesn't make any sense to us. But what makes sense is at any given location, what is the maximum size available there contiguously, and if that available size is less than what is required for an array, then array will be allocated there. Otherwise, we don't find any place for allocation. Though memory is available, our program will say that no memory available, out of memory warning will come. So that's a problem with using arrays. Then the programs, whatever we are talking about, languages, C, C++, and all, they don't have any inbuilt methods for searching, sorting, or resizing, etc. So we have to create our own programs to search, sort, or any such thing, as we have seen in the previous videos while discussing about searching and all that. We have seen that we have written code, so that the user has to write the code. And the problem with the user code is when the user is when any method is defined by the user, then if you think in the operating system level, then the user defined program works at the user level, and it will be quite slow because the priority for the user methods is least when the operating system is performing its work. So if it is built-in method, then the priority of the method would have been better. So we would expect early usage of these methods, so faster uh, what can say faster running of these programs is possible if we had a built-in functions. So if the built-in functions are there, then it will be working in kernel mode. Otherwise, if we have defined our own method, then it will be working in user mode, and hence it will be quite slower. So that's another difficulty we have when we are working with arrays. And definitely there is a possibility of committing errors when we are working with arrays. And of course, scalability is an issue because everything happens at the compile time. So you have to define in the beginning itself before executing any program or before compiling the program and converting it a program language program into an executable program or machine language program. We need to decide what is the size of the array required, and dynamically we can't change this in the runtime. So it is not possible to change the scale of the data. So we can't just increase or decrease the size of the array once defined. So these are some of the disadvantages, and these disadvantages, some of these disadvantages can be overcome through another type of data structure, what we usually refer as linked list. So this is going to solve the problem of the fixed size. Maybe in some cases, insertion deletion can become fast, and then memory allocation problem can be solved, and then scalable issues also will be taken care of. So the problems like fixed size, inefficient insertion, deletions, memory allocation problems, and then talking about the scalability issues can be overcome through the usage of another data structure called linked list. So the next few videos is dedicated for this new data structure called linked list. So please keep watching. If you find the videos of any use, please don't forget to like and subscribe to this channel. Please share this information with your friends and make use of that. Thank you.